Hello there. Welcome to another episode of Mathematical Storytime with Miss Lindell and Ender. I'm Miss Lindell and this is Ender. And we're having fun with office chairs today. So, this is going to be the story, oh boy, of Manfred and Winifred. Manfred is spinning around in an office chair and wants to give Winifred a high five. But, since this is a math story, they want to figure out how fast that high five is. So here we go. Turns out, if Manfred is spinning himself around in the chair just using his feet, like we all did in 6th grade computer class, he can turn himself at 30 RPMs. So, how fast is his hand going then is the other question. If his arm span from his center of mass to his fingertips is 28 inches, because, he's just a kid, right? If I figure out the circumference that circle is, that would be one rotation, right? So that I can multiply it by the rotations per minute to get how fast his hand is going in inches per minute. So 2 pi times 28 is 2 pi r, which is a circumference. So if I multiply all of that, we get 5,277.875 inches per minute. Now, inches per minute doesn't tell us a whole lot because it's kind of hard to reference, at least for most of us. So we're going to change this into miles per hour. So I'm going to multiply by 60 minutes per hour to get rid of the minutes, since I've got minutes on the bottom to start with, minutes on the top to get rid of it. Then I'm going to multiply by 1 foot over 12 inches, since there's 12 inches in a foot, and 1 mile over 5,280 feet, since there's 5,280 feet in a mile. And that gives me about 4.998 miles per hour, which is approximately 5 miles an hour. So that's how fast his hand is going when it collides with Winifred's. So how fast is that? Well, if you think about it, if you're running a 10-minute mile, that's about 6 miles an hour. So not ridiculously fast. They could do it faster if they just, sprinted and high-fived, or if he ran up to her and gave her a high five. But it's a starting place, right? Manfred and Winifred were not happy with that, though. So Winifred said, oops, wrong one. What if I were to push you in the chair? What if it became Winifred powered? Well, it turns out that Winifred can push him at 50 RPMs instead of 30 RPMs by himself. So if I take the old equation that we had and replace the 30 with a 50 RPM, then we do all the same multiplying and everything, and we get 8.33 miles an hour, which is certainly better. But Manfred and Winifred still weren't quite satisfied with that. So they decide to give Manfred longer arms. Now, I know you're thinking in physics class, you probably learned, or maybe you learned, that if you hold something in your arms out and you're spinning in the chair and you pull it back in, you start going faster. In this situation, though, we're going to assume that they're doing the extra work that it takes to push yourself harder so that you can get the same RPMs. So this will increase your linear velocity instead of decreasing it by adding arm length. Okay, so it will take more effort to get yourself to spin because you've got more mass displaced. But anyway, here we go. They're going to give Manfred the wingspan of Shaquille O'Neal. Just fairy godmother it. So now he's got 45.5 inch of a radius from his center to his high-fiving hand. What are you doing, Ender? And because Shaquille O'Neal's wingspan when he stretches his arms out all the way is 7'7". So that gives him a 45.5 inch radius. So self-powered, we keep the same equation as we did the very first time that we did this, but we exchange 28 inch radius for a 45.5 inch radius. So that gives us 8.122 miles an hour. So that's almost as good as if Winifred was powering just regular Manfred's arms. So then if we combine the two methods, if we get Winifred powered and super long arms, then we change this equation, the 30 into a 50, and we do the same calculation to get 13.536 miles an hour. So considerably faster than where we started. So that's all for story time with Miss Lindell and Ender for today, where we tackle the really important life questions. Say goodbye, Ender.